Hi, so basically in this video we're going to be talking about Leetcode problem number 2359, which is our daily problem for today, and this is find closest node to given two nodes. So basically you are given a directed graph of n nodes numbered from 0 to n minus 1, where each node has at most one outgoing edge. The graph is represented with a given zero index array edges of size n, indicating that there is a directed edge from node I to node edges of I. If there is no outgoing edge from I, then edges of I is equal to minus 1. Right? You're also given two integers, node 1 and node 2. Now our aim is to return the index of the node that can be reached from both node 1 and node 2, such that the maximum between the distance from node 1 to that node and from node 2 to that node is minimized. Okay, so you might not be understanding the problem right now because the language is a bit tricky. So I'll explain to you on my sketchpad, but till then let's just complete the problem statement. If there are multiple answers, return the node with the smallest index, and if no possible answer exists, return minus 1. Note that edges may contain cycles. So what our aim is to basically return index of that node that can be reached from both nodes 1 and 2, such that the maximum between the distance from node 1 to that node and from node 2 to that node is minimized. So the maximum between those two distances has to be minimized. Okay, so you might not understand. So let us take this example. One, you can see the graph edges are given, and you basically have to construct this graph. So input is given as this 2 to 3 minus 1, so you won't understand what it is. So let me just draw and show you guys. So basically edges has been given to us. So let me copy this and can we paste it here? No. Yeah, okay, we got it. Delete this. So we have this, right? Edges. Let me just do control Z for a second. Let's paste it here, right? So basically this is our edges. So what this means is that we have basically at the 0th index we have 2, 1st index we have 3, 2, second index we have 3, and third index we have minus 1. So in the problem it is written that 0 index array is given, indicating there is directed edge from node I to node edges of I, right? So from node I to node edges of I, so basically this means that there is a node from 0 to 2, node from 1 to 2, edge from 0 to 2, edge from 1 to 2, edge from 2 to 3, and from 3 there is no edge, that is minus 1, right? So basically the graph that could be formed here is something like this. From 0 to 2 there's an edge, right? And since it is a directed graph, I've shown the edge. Then from 1 to 2 is also an edge, and from 2 to 3 there's an edge, and from 3 it is to minus 1, so there's no edge. So basically this is our graph. Sorry for the bad drawing, but since I'm using my mouse, sorry for that. So basically let me just resize this. Can I select this? Yes. So basically this is our graph, right? So basically what our aim is to basically we have to maximum between the distance from node 1 to that node. What is that node? Index of the node that can be reached from both nodes 1 and 2. So we need to choose the maximum between the distance from node 1 to that node and from node 2 to that node. So what this means is that we are going from, we have to select from node 1 is 0 here, and node 2 is 1. Since in the example is given node 1 is 0 and node 2 is 1. So from this node and this node, we have to go for a maximum distance. So what would be maximum distance? It would be till 3. So distance is equal to 2. So the maximum distance would be 2 here. And from 1 to 1, the maximum distance again would be 2 here. So the distance from node 0 to node 2 is 1, and distance from node 1 to node 2 is 1. So you see that distance from node 0 to 1, 0 to node 2 is 1, and distance from this to this is 1. The maximum of those two distances is 1. It can be proven that we cannot get a node with a smaller maximum distance than 1, so we turn to node 2. So what we found out is that this is the maximum we can go is till here, and we have to print out the minimum distance, right? We have to print out the minimum, the smallest maximum distance that we can go from both nodes. So that is basically 1. The distance is 1, but the node value is 2. So that's why our answer is 2, right? So now basically we can go through this example, and now let's talk about the algorithm. So what we'll do is basically we'll store the distances for both these nodes. So let us say we have distance 1 as the vector that we store for all our other, for going to all the other nodes from node 1 to all the other nodes. So distance 1 is for node 1 and distance 2 would be for node 2, right? So distance 2 would be for node 2, so let me just make that as well. 0, 1, 2, 3, right? So distance 1 is from node 1, so that is node 1 is 0, and distance 2 is node 2, which is 1 in our case. So initially what we do is basically fill it up with infinity because we haven't traversed it, and for traversal we'll typically just follow the typical algorithm of either DFS or DFS. So we'll do that. Just for traversal we'll use DFS or DFS, and initialize these two vectors with infinity for all the indices, and then while we are traversing, so let me just do a run through for this. So sorry, a dry run. So basically from 0 to 0 the distance would be 0 because it's the same node, so this would be 0, So let me erase it. Uh, Basically, let me just, oh sorry, this is fill, right? So basically, here we get 0, since the distance is 0. Then from 0 to 2, we have a distance of 1, right? And then from, or let me just make a new one. So this is the updated distance 1 vector. So from 0 to 0, we have 0 distance. From 0 to 2, we have 1 distance. From 0 to 1, we will just have infinity because it is not reachable, since the directed edges are from here to here and it's not the opposite way. And from 0 to 3, we have distance as 2, right? 0, 1, 2, 3, these are the indices. So this is distance 1 updated vector. And for this, we have again 0, 1, 2, 3, right? So from 1 to 0, it would be infinity because we cannot reach that edge, that node from either of the nodes, node 1 or 2, we cannot reach them because the directed edges do not reach them, right? But from 1 to 2, we can reach by a distance of 1. From 1 to 3, we can reach with 1, and 1 itself is basically distance 0. Sorry, 3 is supposed to be. So basically, we have gotten these values, and what we do is basically we have to just get the minimum of these. So you can see this is the minimum, and that's why we choose these. So basically, you are now clear with the logic, and we just need to apply DFS or DFS to solve this question. And in the next video, I'll be